This is my Toucan stove. You can see it's made of toucans. I learned about them on YouTube, and it uses this principle called TLUD, which is top lit updraft, and that was designed designed originally for a means to create a stove that burned biomass much cleaner for cooking food over. Kind of recognizing that there's billions of people in the world that cook their food using biomass, and it's kind of a sadly common thing that people die of asphyxiation or kind of a respiratory related illness from burning biomass in their homes. So this guy, I'll have to look up his name, invented this thing called a TLUD stove, and that ultimately was kind of distilled down to this Toucan stove, which is much easier to make. What happens is we pack this thing really full of fuel, kind of denser fuel at the bottom, finer fuel at the top, light it from the top, and it's oxygen starved. And so what happens is eventually it starts to pull oxygen in through these holes in the bottom, and so it kind of burns upside down. It's this kind of fuel at the top that's combusting heats up the fuel at the bottom, and that actually pushes out the VOCs and the kind of gases within that wood at the bottom, which ultimately gets ignited kind of up here. And once that reaction kicks in, this thing starts to act as like a jet engine almost, and it'll kind of hum a little bit, and the flames will get really tall. And what's happening is it's burning the wood gas. So it's cooking the gases out of the wood in the bottom of the stove. Those are combusting at the top. And if we put the fire out in time, what we're left with is just basically biochar at the bottom. So there it is, full of feedstock. This is maybe like a worst case scenario because it's mostly spruce in there. Just like leftover scraps of 2x4s and 2x6s, so those are gonna burn really fast. They're like mostly air. So it's gonna go a little quicker. I wish these were a little shorter, but I think it should still work. I just wish there was a little bit more space for some fuel in there. But we'll try it out. Okay, so I've stuffed the remaining kind of space in the paint can with red oak shavings from a draw knife from a chair I made last semester. And those have been sitting around since probably October, so they're pretty dry. And what I'm gonna do is I'm gonna light those, and once they start to kind of get going, I'll put the kind of chimney on top. But I found if I put the chimney on top too early, I started with oxygen kind of too early, and it doesn't have quite the draft yet, and it'll just put the fire out. And I put it on top of some bricks because it's going to require air coming in through those holes in the bottom, like I showed earlier. And so the bricks just kind of lift it up off the ground and let that happen. One way people will put these out once they kind of want biochar, typically people, when making biochar, they'll just douse it with water. But one of the kind of clever things with the Toucan system is, because it's a paint can, you just put the lid on and you take it off the bricks and put it on dirt, and that'll starve it of oxygen entirely and it'll put itself out. Set up a little windbreak with a tarp here, and that should help. And you can see it's just going to start burning from the top. Alright, and once it seems like that's really going to get going kind of without any intervention, I'll put the chimney on here. And I experimented on the time I made this with different placement of holes and everything, and it's kind of hard to get consistent results. And there is this kind of critical relationship between the height of the chimney and where the holes are and everything, so that you get this kind of like secondary burn. Because ideally what's happening is most of the combustion's actually happening kind of in here. Alright, so if you look, it's starting to go pretty good, so I'm going to start timing it. Like I said, this is spruce, so it's not going to go very long. I think I'd be happy if it was more than a few minutes. And you can really tell once it's kind of burnt out, and once we're down to like burning the carbon, the flame will come down to like a flicker. And if we let it keep going, once it got to that point, it would just turn to ash. So we basically want to like terminate it once we're into that kind of phase if we actually want to get biochar out of the end. harder to tell than normal because it's windy enough. You can see we're starting to get smoke out of the bottom. But I think the wind fights with the draft a little bit, actually. Because I've never had it actually push smoke out the holes in the bottom. So that's a little weird. But it's still going pretty good. And you know, you can see the flames and they're still relatively violent. You can see the wood's kind of like red hot down in there, but it's not, I mean, it's still pretty substantial in there. So I actually think we have a pretty good pyrolysis going. I'm gonna put it back on and we'll keep going, see if we can get to a half an hour. At that, we're at 23 minutes 45 seconds, and it seems like it has kind of changed to a different type of flame, and it sounds very different. So I'm going to take off our little flue there and put on the lid, and it's going to start smoking at the bottom. Right, we'll get a little bit of flame at the bottom while it still burns up the little leftover oxygen in there. And we'll carry it over to the dirt. Let's find a good spot here. I'm going to put it in the dirt. We'll hammer the lid on. Yeah, it's going to smoke a little bit as the last little combustion in there stops. And I'll come out in, you know, an hour after it's cooled down and everything, and we'll take a look at what's in there. So it looks like it's about to rain, but this seems cool. And if we look in there, it's pretty full of stuff. So it's not ash. That's biochar. Some of the stuff all the way at the bottom didn't quite get there. All around, we have cans mostly full of biochar. Some of it, you know, the volume's definitely dropped down, so some of it clearly burnt away, but all around pretty good.